Hello, my name is Antonio Hernandez, and today I will be doing the video assignment 3. And today I will be doing it on a bullpen of kid pitching. And yeah, at the very beginning of the video, he's in a static position as his center of gravity is aligned over his back foot. His base of support would be his 2 feet on the ground, and this is going to allow him to stay stable through this position. His momentum's still at 0 because he has not started to move yet, and no law of motion has been applied yet because of the fact that there hasn't been any force causing him to move yet. As he begins the windup, which means he starts lifting his leg and shifting his weight onto his back leg, his base is gonna narrow because we're now on 1 foot. This is gonna mean that our back foot is going to need to be very stable, and our momentum is going to start moving towards home plate, and this means that the velocity is starting to increase, starting from 0. Next is going to be as he starts to move towards home plate, his center of gravity is going to shift forward and downward as we're starting to move down the mound because it is a ramp. He's going to start accelerating in a positive way because of the fact that we are obviously moving down. His drive leg, which is going to be the back leg, is going to apply a large amount of impulse because that's what we are using to start the rotation. And with a higher impulse means a higher change in momentum, which means that our momentum going towards home plate increases, which allows us to throw the ball with a higher velocity. The friction is going to be between our back foot and the mound because the mound is going to help us push off from our back leg, which allows us to put more force into the throw. It's a static friction because it's going to help us stop from slipping while also being able to produce force through the ground. And so as he lifts his leg and his front leg starts to move forward, his BOS is only supported by 1 foot. So this is going to change our center of gravity, and it's obviously, how I said, moving towards the target, creating momentum. And as we are doing this, the trunk and body are gaining velocity, and then the arm is what we call a cocking phase. So it means it's coming up and it's going to reach external rotation, which is going to store a lot of energy as we are going to come through. The acceleration here is still positive because we're starting to peak through to like get through our release. The force that we're looking through is hip-shoulder separation, meaning our hips are pointing towards home plate and our shoulders are still back here, which is going to allow us to rotate at a higher pace. And next is going to be our foot lands. The BOS increases once again because now we are stable on 2 feet, and this is where the laws of motion come into play. Well, obviously they've been in play, and this is the third law of motion because once the foot strikes, it's gonna release the force back up, and it's gonna help us get over the ball because the force is going into the ground and it's gonna push back, and we're obviously in a position to where we're rotating, and as we rotate, we're gonna release through the trunk and it's gonna release into the arm. And as the arm starts to accelerate forward, this is our highest point of acceleration because this is obviously the fastest moving through the motion of releasing the ball. It's obviously quick, so like this is the fastest. It's going to be the quickest. The ball leaves the hand, and as soon as we start to release the ball, our arm starts to slow down, and this is because it's natural. One, and second is if we didn't slow down, there would be a great increase of energy. The point here is when we are on 2 feet, our friction is with the ground or with the mound, and this is going to help us anchor ourselves, allow us to release all the rotational forces that are being applied through the throw instead of being unstable. And because if we are unstable, we're going to lose momentum through the throw. So when both feet are on the ground, our stability is very strong, which allows us to release the ball at a high rate. Like I said, after he releases it, we start to decelerate and slow down again. And this is gonna, slow down so obviously at the throw, it's gonna be released at the force, like the strongest force is gonna be here. And after that, we need to slow down because it's obviously the opposite active force that is being applied. And then, yeah, so overall, we can see that the acceleration goes from positive to negative as soon as we release the ball because we do slow down. The changes of impulse, the impulse is starting at 0, and then we start to, pick it up as we go. The changes in the BOS are obviously when he lifts his leg and changes his momentum starting to go forward. And then once again, when he lands, he gets a stronger base. The first law is relevant because he is able to rotate as he lifts his momentum and gradually continues moving forward. And then the third law is relevant because of the fact that we are able to, when he lands, the force comes back up that he's putting into the ground comes back up, and it allows us to get rid of it throwing the ball. And so with the friction, it's going to be with the ground. It's going to be base friction, and it's important for force and to stay stable, because without a stable force, then we would be all over the place, not allowing us to release the max amount of force into the ball.